Welcome to the Meteor Spacecamp 2015 video series. These were a series of videos recorded in the mountains of Gatlinburg, Tennessee during the Meteor Spacecamp 2015 event that was held in October. If you're interested in more information, please check out meteorspace.camp. Also, a big thank you to our sponsors. Our gold sponsors were Modulus. You can find them at modulus.io for all your hosting needs, whether that be Meteor or Node or PHP. They can handle all that for you easily, modulus.io. And also okgrow.com. If you need to have an application built, okgrow is the place to get it done. Give them a shout over at okgrow.com. And also Meteor Club. You can sign up and join Meteor Club at meteor.js.club. It's a weekly email. You get tips and tricks about Meteor and other relevant news. So if you're interested in that, check it out, meteor.js.club. And also Compose, our silver sponsor, compose.io. They're a great place to host your database, take care of any database needs you may have, whether that's Mongo or Elasticsearch or any number of platforms that they're supporting now. I use them for all my production stuff, so I highly recommend it. Compose.io.
So I want to talk to you guys about why you should always check your arguments. But before we get to that, I should probably introduce myself. My name is Pete Corey. I do a lot of blogging about Meteor and Meteor security on blog.east5th.co. I also run a small freelance Meteor development shop called East5th. So I've always loved software security. My first job was actually as a security consultant and tester in college for a company called Cigital. We did a lot of penetration testing, but we would also go in and manually. So I would basically get paid to hack websites, which is a lot of fun. But I realized that when I talked to the developers who built those websites, I wasn't able to kind of articulately explain why the vulnerability existed or how to fix it. And that was kind of a big problem because I wanted to help them improve their websites and their applications. So I realized that I needed to become more of a web developer to kind of get that background to help people make their web applications more secure and more robust. So I graduated school, worked for a few companies, got a couple government contractors, Amazon. I worked as a remote contractor for a while, and now I do freelance web development. And I also offer security consultations. So Meteor, to me, is kind of interesting from a security standpoint for a few reasons. The main reason is because of probably DDP. DDP lets us pass pretty much anything that's JSON encodable into a method or a publication or a collection validator. And that's kind of a step beyond where we were previously with REST endpoints, right? So with normal REST endpoints, you would have your GET endpoints that would really only accept strings. If you want to use like a number parameter, you would have to explicitly coerce that string into a number with a parse int or something. So you always know what type it is that you're getting. But with DDP, you can pass a number, you can pass a string, you can pass an object, you can pass an array, you can pass an object filled with arrays of numbers of strings. You can do all this kind of stuff. And when it comes to dealing with those arguments in your publications and your methods, you kind of don't know what you're working with. And that can cause some real security problems, as we'll see pretty soon. So when I say check your arguments, what exactly do I mean? Well, I literally mean check your arguments. Check is a tool in the Meteor framework. It's a small little library that basically asserts that the thing you're passing into it is the type you expect it to be. So, for example, I can call check on a variable called user ID, and I'm expecting it to be a string. So if I pass in a user ID that's like, just a string of characters, and it comes to this line, it'll pass right through, happily. But if for some reason I pass in a number for user ID, this is going to freak out, throw an exception, and give you something like this. It'll say it expected a string, but it got a number. And because it throws an exception, it basically prevents all following server code from running. So you won't get into a bad state in your methods or publications. So why does this matter? I'm going to show you a few examples And for these examples, I want you guys to take off your developer hats for a minute and put on hacker hats. I want you guys to think like users. So let's try and break these examples. We're trying to steal user data, cause application downtime, steal products, do all kinds of bad stuff. So I'll walk you through a few examples. The first one's pretty straightforward. So let's pretend we have some kind of imaginary web app that's like a shopping cart. So this shopping cart has a publish method on the server that publishes a single cart document. And we take in the cart ID of the document we want to publish, and we return a carts.find of that cart ID. So this is pretty straightforward, right? We just want a cart, so we give it the ID, and it returns the cart. But if you remember, cart ID can really be anything because we're passing in that value through DDP. In this case, we're expecting it to be a string, a Mongo ID in the form of a string. But we can just as easily pass in a number, or an array, or an object. So one subtle thing you can do is you can actually pass in an object that is a MongoDB query operator. So you control Mongo through objects. So basically, if you pass in this object as your cart ID, it would replace cart ID in the find with that object. So now your query looks like this. You're basically saying find all carts whose ID is greater to or equal to an empty string. So that's going to publish every cart in the system, regardless of whether you own it or not. And that will surely, leak some private data to people who shouldn't see it. This is also an issue because, well, this is the fix, sorry. So basically, to fix that issue, you would check that cart ID is a string. So if you pass in an object or a number or anything, it's going to hit this second line of the method, of the publish call. It's going to see that cart ID is not a string, and it will throw an exception back to the client saying, I was expecting a string here. What are you doing? And that'll prevent all that private data from being leaked. So this also works in methods. Like I said, anywhere that accepts DDP input is vulnerable to this if you accept arguments. So in this case, we're taking in a cart ID again. The whole point of this method is to remove a cart from the system. So say you want to clear your shopping cart in our application, you would call this method and it would actually remove the cart object from the system. So it's taking in a cart ID, and what we're doing is we're finding the first cart that matches that ID. So you find the cart. We're checking that that cart belongs to the currently logged in user, and then we're deleting it. So that seems pretty secure, right? We're checking that the user owns the cart before they delete it. Awesome. But what happens if we, again, pass in an object here? What if we pass in something like ID is greater to or equal to a cart ID, like my cart ID? So let's say that I have a cart in the system and it has some ID. So what if I substitute that in for that little string right there? We sub that into the original method. Our find one becomes this kind of complicated thing that says find one cart whose ID is greater to or equal to my cart ID. And so depending on, I think, whether you have an index or not, but depending on the natural sort order of Mongo, if this was just a find, it would return all carts whose IDs are, I think either created after your cart or lexically greater than your cart. So either statistically like half the carts in the system or a good number of them. Find one grabs the first result off of that list and returns it. So that'll always be the cart you own. So this check right here to see if we own that cart is always going to pass because our cart will always come first. So we come into this remove statement, but now we're removing all carts whose ID is greater to or equal to my current cart ID. So this is going to remove a ton of carts potentially, up to half, maybe fewer depending on your Mongo order of things. So we've just basically destroyed a bunch of people's carts, which is not good. This kind of thing is also really relevant. Well, this is the fix for that. Sorry. Again, check that cart ID is a string. Pretty simple. If cart ID is an object, it's going to throw an exception there, break out of the method, return a message to the client saying this should be a string, not an object. What are you doing? Please stop. This is also applicable in collection validators, so your updates and denies. This is kind of less commonly used here, but I have a pattern that I like to use for securing allow and deny methods that I think works pretty well. So in this case, we have an update method, we have a deny update method on the users collection. So we're trying to basically deny users who aren't already admin users from adding another role to their roles collection. So this would basically be like how someone makes themselves an admin. They would do like an add to set of roles with admin. We want to prevent them from doing that. And this seems fairly straightforward, but what happens if they don't use add to set? What if they use something like push, if they push the admin role onto their user document? Or if they just set their roles field equal to an array with admin in it. So both of these things are going to slip by that original deny method because we weren't checking for push or set. Right? So my fix for this kind of thing would be to move away from using deny and use allow with check's cousin, which is match.test. Basically, I create what I expect each possible update to be. So for example, I always expect change roles to be an add to set where we're adding a string to roles. That's that first line. And I always expect change username to be a set where username is a string. And depending on the user's role, they can do either one of these or both of these or a combination of these things. So for example, if the user is an admin, they can do one of change roles or change usernames. They can change their roles or another user's roles, or they can change their username or another user's username. If the user is not an admin, they can only change their own username. And so match.test is a lot like check, except instead of throwing an exception, if that comparison fails, it's going to return false. So here, we wouldn't throw an exception when that fails. So if like a normal user is trying to update their roles to include admin, it would just return false, which would prevent that allow from happening, or prevent the update from happening. So why should you be checking? Most of the examples I showed were NoSQL injection issues, but also the last example was a kind of a demonstration of the fact that Mongo modifiers are very hard. They're hard to get right. There are almost 24 different Mongo operators. Most of them, well, some of them do very similar things, just subtly different. So you can easily swap one out for the other. So if you're preventing push, someone might be able to use add to set. If you're preventing set on a number, someone could use inc or bit, which would do like increments or bitwise operators on that number. There's a lot of different combinations here, and it's always better to only allow the certain ones that you expect rather than blacklisting ones you think are bad, because people will always be more clever. They'll come up with ways of bypassing your blacklists. So the better way, for sure, is to only allow certain updates that you expect. As I said, most of the examples I showed were NoSQL injection. This is kind of like an evolution of the old SQL injection. Back in the day, people used to construct SQL queries with strings, and if someone said their username was single tick, semicolon drop tables, semicolon dash dash, it would run a query that says find all users whose username is empty string, and then drop all the tables in the database. So this is kind of an example of an extension of that. We're not concatenating strings together anymore. We're kind of concatenating objects. So this is called NoSQL injection. And also, the biggest reason is that users lie. It's kind of hard to acknowledge that when a lot of what we do is built around the fact that we should serve users and our app should be user-centric. But there are malicious users out there who will lie about their rights, lie about their privileges, try and steal things from your users and applications, and just try and break things. So you always need to be cautious and defensive when you're programming. So where should you be checking? I kind of touched on this already. You should check anywhere that accepts arguments. So in a Meteor application, this is going to be your methods, your publications, and your collection validators. That's kind of the three biggies in the Meteor security landscape. If if you're exposing REST endpoints, you should probably check there too, but that's kind of a separate thing. So methods, publications, and collection validators. And there are a few tools that'll help you guys check your arguments. The first of which is audit argument checks. And this is a Meteor package. You just add it to your app with Meteor add, audit arguments collections. And this is a runtime check of all the arguments you're working with in your methods. And I think publications as well. So if you call a method that has an argument passed into it, and that argument does not get checked anywhere in your method, it's going to log an error on the server, and I think throw an exception back to the client. But it's important to note that this is a runtime check. So as you're building your app, you won't be notified that you're lacking check coverage or that you may be potentially letting arguments pass through. Another great tool that I didn't talk about in this talk, but is awesome nonetheless, is Simple Schema. And you can basically define what you expect your documents to look like in the form of a schema. And then you can actually just drop your simple schema directly into your check. So you can say, like if you're accepting a profile as an argument, you can check that your profile is equal to that simple schema just directly. No real added complexity there. And if any fields exist that aren't in the schema, or any fields are different types than are expected in the schema, it will fail that check.
So you're thinking of the text that simple schema does are pretty good? Or sufficient?
What I'm saying is that you can drop a simple schema into the second argument of a check. So instead of saying like check user ID string, you can check profile, your profile schema, and it'll run through all those fields, check them for you. And then the last tool is a little bit of a plug. I have a package called East5th Check Checker, and this is a good complement to audit argument checks. It does pretty much the same thing, but it does it at compile time. So it does a static analysis of your code. It looks for methods and publications that do not have proper checking being done, and it reports all of those in your server logs on startup. So for example, if you have like a method, it isn't being checked, like it has an argument called foo, and foo isn't being checked anywhere, it would say, you know, warning, method blah 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 in file blah 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 is not checking argument foo. And so these two go great together. Yeah.
That's in the packages as well.
Yeah. Well,
So we check the packages using the application.
so it'll check your package code, and if you use it like a local package, it'll check that, but it won't dig into your local Meteor install. Yeah. So the bottom line is that check is your friend. Always use check anytime you're taking in user input from anyone, anywhere. And as a fun little demonstration of what I mean, and to make things real for you guys, I'm going to go ahead and do a quick demo. So this thing is actually a Meteor app. So if I bring up the console, you can see that it's a Meteor app. Oh, yeah, sorry. Bigger. All right. So I actually forgot what. All right, so I have a publication called Cart. So this is the first example we showed in the presentation. So right now, there's a carts collection. But if I do a carts.find, I'm going to have no documents in it. But what happens if I do a Meteor subscribe? I subscribe to cart. And I pass in an object, say, or ID greater to or equal to an empty string. So when I do this, it's going to make that subscription, which if we look at the code, don't know if I can make this bigger. No. So this is the publication. So it's going to take cart ID and substitute it into this find right here. So that's going to find all cart ID is greater to or equal to an empty string. And if we look at our carts collection, we can see that that's all the carts in the system, which is something we probably shouldn't be able to see. So let me refresh this really quick. And I also have a method in here called getCart. And get cart accepts a cart ID again, and it runs it into a find one. So there's kind of a fun for me, not fun for the application, query I can pass into this that would basically DOS the entire database or the entire server. So MongoDB has a query operator called where that accepts a string, and that string is interpreted as JavaScript on the database. And it's supposed to be used to do complex of your documents, so you can do like job comparators and comparisons on your database of actual fields of the document. But you can pass in any, or just a full V8 engine. So you can actually drop in infinite loops or do whatever you want. Let me see if I can do this. So we call, actually, so here's another cool thing. If I don't know what methods exist in the project, I can look at my Meteor connection and I can drill into method handlers. And if it's defined in a shared location, I can see this getCart or getCart method, and I can actually grab the source of it. And so I can see that the cart ID is not being checked, right? It's just passed directly into here. So as a client, I can see that your app is insecure. So I can then go ahead and call meteor.call getCart. And I can say where.
I think you want cart, not cart.
Yeah. So let's see. I wonder if I can just do a while loop here.
And this will conclude your presentation.
So it doesn't like just straight up while. Let me really quickly. I don't want to mess this up. And I have no internet. Yeah. All right, so let's do it live. Up. But basically, it would spin my database at 100%, preventing any more incoming connections from making any queries against the database, essentially DOSing their app. You should go to my blog, blog.eatsfifth.co. I think I'm something in there. I'm not sure what. But basically, the bottom line is that you need to be very careful about what you take in from the clients, and you need to be very careful about things directly into queries. Everything is dangerous. Find one, remove. You need to be careful with everything. And there are tools out there to help you, so feel free to check those out. And these are kind of contrived examples. If you want more examples, like more real-life, in-depth examples, check out my blog. Or come talk to me afterwards.
While missing closing paren.
Man, savior. Okay. Well, this is a lot less impressive than it should be.
It's scary enough already.
Yeah. Trust me, it works. I did it earlier. I promise. Not sure what's going on. But any questions?
Just like when the crater goes down sometimes.
Yeah, that's all me. Yeah. I'm just trying stuff out, you know.
What's the most famous thing you've hacked so far in a Meteor app?
I don't know, man. Famous? Was it getting the list of
I would say.
Galaxy users? Yeah. So Meteor had a website that was publishing all the users of Galaxy in closed beta, and it was just publishing that data to the client. Anyone can find it. So don't over-publish either. That's also bad. Any more questions?
So theoretically, you can write a server.
So like you're talking about in the database right here, in this code?
No, I mean, let's say you have a security company.
Yeah.
So you can write an app, so you can give a URL to users.
Well,
A pen test.
I offer security assessments, but I don't have like a fully automated way to do that. It's more of a hands-on process. Fully automating it would be very cool. I should strive towards that.
That's only $1,000.
Yeah.
$1,000 for me to stop the DOSing or something.
Yeah, exactly. Just send a ransom note.
Then Bitcoin's here.